Like I said, access modifiers is a bit of a big topic. So we're going to take our time. We're going to go through quite a few slides so that we understand how it works. So access modifiers define the accessibility, the visibility right. It pretty much tells a method, also a class or a variable. You can use these on classes and variables as well. We're just going to focus on methods for now. So it defines, what parts of the Java program can actually access that method. So real sophisticated programs in Java usually have multiple classes. We're going to actually be writing programs with more than one class. I know we've been sticking to the main class, but soon we're going to graduate to actually use more classes. Technically, we've been bringing other classes in, right, when we do our imports. But now we're actually going to be writing our own classes. We're not going to be relying on the pre-built ones from the Java JDK. So when you're writing methods, sometimes it makes sense to restrict the access. Other times it makes more sense to open it up. We'll talk about the restrictions in a later lesson, but we will talk about the access modifiers that actually do that. So remember, access modifiers, that's that first token when you're defining a method. Uh, let's look at the different types over these next few slides. All right, so Java provides four main access levels. We have the public, wide open, we have private, restricted, we have protected, a little bit in between, and then we have default, which is very similar to protected. So let's go with public. It means that, so this modifier means that the method can be called from anywhere in the program. Anywhere means any class in the program can call on that method. So if you have 10 classes, right, all 10 classes can use that method. So use this modifier for methods or classes that should be usable from anywhere in the program, even by code and other packages. Just like you can have multiple classes, you can have multiple groups of classes. Remember, a group of classes is called a package. That's for more complex programs. We're not quite going to get there in this class. All right, maybe you want to restrict things, right? We're not going to take a deep dive on why you would restrict things yet. We have to learn a little bit more about classes before we get into that. But the private access modifier is if you want to restrict it to only use a method inside the class it was created in, it was defined in. So private methods can only be called by the same class they were defined in. Use this modifier for methods that should only be used within that same class they were created in. This helps enforce encapsulation and data hiding. Two important topics, really one important topic in object-oriented programming. We're not going to talk about that today. I don't want to overwhelm you. We'll save that for another lesson. But just know sometimes it is better to restrict the access, and you do that with the private access modifier. And again, we're actually going to build a method over the next few slides. Another one is protected. Protected is a little bit in between public and private. So it can be called from the same package it was defined in, and any subclasses from other packages. So if your class was inside a package and there's like 10 other classes in that package, if you use protected access modifier, that means that method could be used by any of those classes in the group. Subclasses has to do with inheritance. Notice there's no star on this slide. That's because we're not really going to use the protected in this class. A little bit advanced. But yeah, just know that this is one of the access modifiers available in Java. It does require knowledge of inheritance. It's not too advanced, right? But again, we're learning one thing at a time. We don't need to overwhelm ourselves with extra stuff. But just know protected, kind of in between. Default is really similar to protected, almost identical. Um, this level of access is used by default. So if you don't put an access modifier, by default, it's going to use this level of access. So it's similar to protected because it's going to give access to all the classes in the same package. The difference is it doesn't provide to the subclasses. Remember, that's an inheritance concept. Again, we're not going to cover this. No star on this slide. So for our class, we're probably going to be using the public more than anything. Um, we'll definitely talk private, especially with regards to classes, and some of the methods, and of course some of the attributes, which remember those are class variables. So yeah, just for the most part, we're going to use public. Don't worry about protected or default, and then private. We'll talk about that more in a later lesson. All right, so we've talked modifiers. Now we're ready to actually move on to the next token, right? Which is return type. So the return type of a method defines the type of data that the method is expected to return. Return is a synonym for output. So what is this method going to output? What type of data is going to output? That's what you put here. So if you want it to output an int, you'd put int. If you want to output a string, you could put string here. If you wanted to output a array of, I don't know, doubles, you could actually put double array here. You can return anything you want. But yeah, you have to define it here after the access modifier. So return type goes after the access modifier and before the name of the method. So right in between. The return type tells Java what kind of value the method will output. That's useful when you're assigning that return value to some variable. Just like we do like to lowercase, right, with strings. And then we assigned it to a variable. That's a method outputting something. It's returning something that you can actually assign to a variable. So that's return type. That goes after access, before method name. If you want the method to output something, you got to put it. You got to define that in the return type. So return statement, like I said, we'll touch on this. Well, if you have a return type, you actually need to tell the method inside the body, usually at the end of the body, um, the actual value you're going to return. So here's the type, here's the value. So if I said string, right, I should actually return a string value down here. Maybe a name, right, or um, a phrase, right, or a message. Anything that's string type, right, if I put string here, has to be a string value down there. So return statement uses the return keyword. The value does have to match the type defined in the return type. Will not only define the output value, but also exits the method. So whenever the method encounters a return statement and says, oh, I must be done, so it's going to exit the entire method. This is similar to break. That might not seem that interesting for now, but once we get to some like more complex examples of methods, you'll see that the return statements, that exit behavior is actually pretty important. Well, it turns out not all methods need to return something, right? Some methods just do stuff, but we don't actually need it to shoot out a value to us. It doesn't always make sense to have a return type. Well, in this case, you would use the void return type. This is a special return type that indicates a method will not return any value. So you actually have to explicitly tell Java, hey, I don't have a return type, I don't have a return, so I'm going to put void to let you know. Otherwise, Java would be like, well, what's going on here? So use this for methods that perform actions rather than compute some value. If you don't need to hold on to the value or reuse it, then you don't need a return. You would use void. Um, so yeah, you don't need a return statement for void type methods, right? If you don't have a return type, then you probably don't need to return a value. You can optionally still use a return statement with nothing in it, right? It's return, but there's no value after it. So it's still useful for its exit behavior. So if you want to exit the method right immediately, you want it at the last line right of the body, you could definitely use it. You don't have to though; it's optional. But again, if you want to, simulate that break behavior, that exit behavior, again, that'll make more sense when we look at the more complex examples. You could definitely throw a return there. Totally optional though for void. For return type methods that aren't void, non-void, you do have to put a return statement. Remember, it has to match up with the return type. If you put a return type but no return statement, that will definitely give you an error. If you put void, then you don't have to worry about the return statement. All right, now we have params. We're almost done building our method. We'll build one together over the next few slides. So parameters, aka params, arguments, or args, those are variables listed in the method's declaration that help describe the input, the data you're going to pass into the method. What does this method need in order for it to work? So if the method return is the output, the params are the input. There can be any number of params. They just have to be separated by commas. So if you have 100, right, just separate each one by commas. If you have 100 params, right, that might be too many. For the most part, we'll probably have just a couple, maybe one, sometimes none. So you have to indicate the data type and the name for each param. So it's going to look a lot like you're declaring an empty var. So you're not initializing, right? You're just declaring. That's exactly what it's going to look like in the params. So parameters have local scope. So these variables that you define, right, they look like variables. Again, we call them params, though, parameters. Their scope exists only inside the method. So whatever you define here is not going to exist outside the method. So remember scope, right? Wherever a variable is defined is where you can use it. So for methods, wherever you define the params, whichever method you define the params for, it's only going to be usable in that method. Remember, variables are limited in scope, namely their declaration block. So think of params as like input variables. So let's finally build our method. Again, I said we're probably going to go with public, so we are going to throw the public in there, but we need something to aim for, right? I know in a previous video we did the dog's age from human years to dog years. Apologies for the video because I mixed up those two terms. I said from dog years to human years. It's confusing. But anyways, we have our dog's age, right? And because dogs don't live as long, you have to multiply it, right, by a certain number to calculate their true age. So yeah, that's what we're gonna do with this method. It'll take a dog's name and age in human years, and it'll give a personalized message with the dog's name and their age in dog years, right? Their real age. Really, it's like a relative age. Okay, so let's see. Public, that's going to be our access, right? We just want it wide open. If you restrict the method, right, and then try to access it somewhere else, you'll get an error, right? So just to avoid those errors, we're just going to make it public, just wide open. We're not going to worry about private until the next lesson. All right, so we made it public so that we can call this method from anywhere in our program and not worry about any restricted access errors. Return type, we don't actually need to hold on to the value. So we're going to make it void. I don't actually want to, return anything. Now we need a name. Good name could be calculate dog age. Maybe it should be, convert, to dog years. It's really up to interpretation, right? We're just going to go with calculate dog age. That's good enough for now. But yeah, really think about your method names. It is important because the more descriptive the name, right, the easier it is for another programmer to come in and say, hey, I know exactly what this method does. So maybe calculate dog age, I would argue not the best, but we're going to stick with it. All right, so we got calculate dog age. All right, let's see. We've defined the output type via the return type. So we did void, right? So now let's define the input. So we're going to need the dog's name and the dog's age in human years. So those are the two inputs, the dog's name and the dog's age. Well, name has to be string, and age, we're just going to we're not going to do like any decimal value. So we're just going with int for the age. So we're going to take a string value and an int value as input. And we name them dog name and human age. So that's our inputs here. And it looks just like you're declaring a variable. There's no semicolon, right? And we separate our parameters, with a comma. So remember, the input of a method is called a parameter, the arguments, the args, the params, whichever term you want to use. All right, now we actually need to make the method work. So we have to actually do some coding. We need to write some statements. So we got to perform those calculations using the values that were passed into the input params. So we need to take the dog's age, right? Specifically their human age, right? The normal years, and multiply by 7 to calculate their dog years. And then, of course, we need to print out the message. That's why we take in the dog's name, so that the message can be personalized, right, to the actual dog. So that message will have the dog's name and their dog years. And here it is, right? So int dog years, it'll take that input param of human age and multiply it by 7. And then easy enough, we can print out the dog name is dog years. So that'll be like a number. So it could be like 12, for example. Or let's think of a multiple of 7. Let's say the dog is 10 regular years. Let's go with my dog, actually. My dog's 15 regular years, which is a lot. So 15 times 7 is 105. So it would say Changa is 105 dog years old. That would be the personal message for my dog. Yeah, her name is Changa. All right, so because this method has a void return type, we don't need a return statement. So we're technically done. If you did want to return the dog years value, you'd have to change the return type, and then you'd have to add this return statement. So then you could assign right that output to a variable. We'll see what that looks like right in some of the examples, but we actually don't need that in this case, so we're just going to leave it out. So our method is done. It's void, so no return type. And that's it. So now this method, you can call in it. All you need to do is use the name and then pass the inputs. Again, we'll take a look at some examples. But yeah, that's building a method. Let's look at some more complicated examples. This is a really interesting one. This one has a conditional return. So this one's going to take a temperature value as an integer, and it's going to return based on a condition. So there's actually two returns. So it says if the temperature is greater than 30, it's going to return this message, a string message. Otherwise, it's going to return this message, which it's comfortable, right? It's actually not hot. So another string message. You can totally do this. You can have a conditional return. There are some things to be careful with. So always cover all the paths. So if your conditional has a path without a return statement, it's going to trigger an error. So every single branch has to have a return because there shouldn't be a single case where it won't return anything. You have to avoid that. And that's a common mistake when you're using conditionals as a return. You might forget to put the return in the else statement. That would trigger an error. Maybe you forgot to put the return in the if statement. If it's a really long one, right? Maybe it's a switch, or maybe it's if else if else. You forgot to put a return on one of those branches, it will trigger an error. So yeah, ensure every single branch leads to a return. Otherwise, you'll get an error. Also avoid unreachable code. So don't place another return after conditional return because it won't be reached. So if you try to throw another return outside this if else means that these are the only two scenarios. Either this is going to happen or that's going to happen. So if I throw a return down here, under the conditional branch, that's never going to be reached. It's unreachable code. In fact, the compiler, your IDE will tell you, give you a nice little message and say unreachable code. We'll take a look at that during the demo. But yeah, conditional returns, totally possible. So you're kind of, putting a conditional, you're putting a return statement. They had a baby, boom, there you go, conditional return. So you can actually return an entire array. So I mentioned that very briefly. For the return type, you can put anything you want. It could be a class, it could be a string, right? A string is a non-primitive. It could be a primitive, right? It could be an integer. It could also be an array. So this is going to return an integer array. Let's actually take a look at the details of what this method does. So it's going to take two integers as input. Then it's going to take those two numbers, right? A and B are the inputs. And it's going to double those numbers. This is really interesting because you can actually do math when you're initializing an array. So notice the curly braces, right, is when you know what the array is going to be ahead of time. You can actually do math inside of it. So we're doing A times 2, B times 2. So we take both those values, we double them. If you wanted to return both values, you can't have return A and the return B. Remember, the return statement exits. So on the first return, that second return is going to be unreachable. You can only have one return unless you have a conditional, of course. So if you wanted to return the two values, your best option is going to be an array. So this int array, right, is going to make it possible for us to return not just one integer, but two. But of course, it's not just the regular integer type, sorry. It's an integer array, an int array. So it returns the entire result array here, which is two numbers, right? It's the double of whatever those input numbers were. So let's say we passed in, let's draw on the screen for a bit. So let's say we passed in, get my pen ready, 5 and 7. Well, the double of 5 and 7 would be 10 and 14. 14. I'm not even going to try to draw the curly brace. We're just going to go like that. So 10 and 14 is my array. So that would return an array containing 10 and 14. That's what that method would do. So yeah, depending on what I input is what that output array is going to look like. All right, so just like you can output an entire array, you can also input an entire array. So this method takes a whole array as an input parameter, and typical with any array, right, we're gonna throw it in a loop so we can print it out. So it takes any string array as input and calls it names. So it might be like names in a classroom, right? Names in some group or company. And this method is going to loop through the names, right? We have our classic array for loop to iterate through the array. It's going to print out the values one by one. It's going to personalize the message, right? Name number one, and then it'll actually give the value here using the index, right? Using the counter as the index. This doesn't return anything, so we make it void, right? All this does is print out messages. We don't actually need to hold on to any of those values. So yeah, that's array as input. And of course, sometimes you don't need any parameters, right? That's totally fine. So this example method has no input parameters. Here's how it works. So it has a string array called greetings. So that's inside the body of the method. It's not an input. It's hard coded into the body. So these greetings have several friendly messages. And then the index variable is interesting. It's going to generate a random number between 0 and the length of the greetings array. So it's going to be within the bounds, right, of that greetings array. So what that index variable is going to hold on to is actually just a random value. Math.random is going to help us generate a random value. This math here, you can definitely use it maybe in some other code someday, maybe in um, one of our assignments, depending on what I assign. But yeah, if you want to generate a random number within the bounds of the array, this is actually the code for it. So random greeting is returned using the random index stored in the index var. So index, it's going to be any one of these, right? It could be 0, it could be 2, it could be 0, 1, 2, 3, 4, 5. It could be index 4, right? Index 4 is for the fifth string here, greetings. Remember, it's 0 base. We start counting at 0, which is very, very confusing, I know. So yeah, this will give us a random greeting essentially. That's why we use the random index to actually return a random greeting. And yeah, this is a string type, not a string array. It's a string value because when we access a specific value from the greetings array, we're actually just accessing a string value, a string literal. So yeah, that's get random greeting. No input params. You don't always need one. All right, so next up is going to be calling methods.